the sum of the formula from scratch. This formula may or may not be given to you, so it's best to understand where it comes from. If we want to add up the geometric series, we'll be adding these terms, right? So ar to the power of all the way to ar to the power of n minus 1, because that would be the last term of our series. Now, if I multiply this sequence by r, that means I'm multiplying the left and right side of this sequence by a ratio of r. This is just for abstract purposes. So what we get is r times s of n equals to, notice the very first term will have ar in it because we multiplying every term by r. And the last term of this sequence will have ar to the power of n because we multiply every term by r. Let's label these two equations, and 1 and 2, and subtract one from the other. If we say 1 minus 2, we'll have on the left this expression, and on the right, everything in the middle will cancel away. After all, that's the kind of trick we want in apps. What we left with, a is on the right is a minus ar to the power of n. Now we can tidy this up. We can factorize s of n out of the left, and we can factorize a from the right. Then we divide both sides by 1 minus r, and we end up with the expression that we wanted. Now, if you did this other way around and you subtracted 2 minus 1, you would end up with the expression r Sn minus Sn. And on the right side, again, everything will cancel out, but you would have ar to the power of n minus a. I'm just showing you a different derivation of the same formula. You would factorize s of n out of that, and you would have r minus 1 in the bracket. And you would factorize a out of this, and you have r to the power n minus 1. You could have divided by r minus 1, and you would have ended up with this formula. It's up to you which version of the formula you want to use. Most people prefer to use this one on the left because that's the one given in the book. So let's use this formula to solve some problems. So, in the first example, we've been told to find the sum of the geometric series for 10 terms. So first we see that the first term is a 2 and the common ratio is 3. So let's note them down. And we know the formula on the top right corner. So we're going to use value of n to be 10, and what we get once we substitute the correct numbers in the correct place into the formula, we'll get 59,048. Okay, in the next example, we have the first term to be 1024, and the common ratio is found by dividing the second term by the first term. That's simply a negative half. I've done the work for you. So, we've been asked to find the sum of this geometric series, where the last term is a 1. So, we don't know what value of n is. How can we calculate the n? This is, after all, what we need before we can use this formula up here. So, we say, how many divisions does it take to get 1024 to 1? We know that the common ratio is a negative half. We can just simply use a half ratio. Now, we do need to use the nth term formula and work backwards to figure out the value of n. But that involves taking logarithm of r. Okay, so un here equals to a times r to the power of n minus 1. we're going to substitute a and r into this formula and put 1 where un is. Alright, so notice that this value was negative half, the r value was negative half. I'm using a positive half here because I know ahead of time I'm going to take logarithm of this expression here, and I cannot take logarithm of a negative number. It doesn't matter. The positive version of r will give us the exact answer that we need for whatever as long as the absolute value of r is half. So to solve this equation, first you divide by 1024, and then you're going to take the logs, t-logs, take log of both sides, and then n minus 1 will be a factor at the front. You're going to divide by log of a half. Okay, if you remember from my previous rant in a different video, I said if you have log of a number and that number is less than 1, this log will be a negative value. Alright, so half is less than 1. Yes, it's bigger than 0, that's great, but if this value is less than 1, you can check it on your calculator, it's negative. So if it was an inequality, you would have to flip the inequality sign. But here, that's fine, because log of 1 over 1024 is also negative. Two negatives divided by each other will give us a positive 10. So, and the last step is to add 1 to both sides of this equation, and we'll have 11. So now we know the last term is the 11th term. Now we can use this equation, the equation on the top right corner. So what we do is substitute a, r, and the value of 11 for n. What we end up with is 6,683. So in this next sequence, in the next geometric series, we'll have a value of a to be 1 and r to be 2. We've been asked to find the least value of n such that the sum of this series exceeds 2 million. So let's note down what we just figured out. We don't know what the value of n will be, but we will calculate it using this sum of n terms formula for geometric series. And we need this sum to exceed 2 million, so that's 2 with 6 zeros. Alright, let's write the inequality. Which way do we write the inequality? The formula has to be bigger than 2 million. Okay, so first we can solve it with an equality sign, and then we take care. Let's look at the next example together. In this question, we've been asked to find the least value of n such that the sum of this geometric series 1 plus 2 plus 4 plus 8 will exceed 2 million. Right, so first thing we note from this question is the value of a and r. A is 1 and r is 2. But we don't know what the value of n is, and that's what we're trying to figure out. We do know the sum has to exceed 2 million. So we're going to write our formula and indicate that the formula will have to be bigger than 2 million. That is, the crocodile mouth will rather eat the formula than 2 million. So we write it like so. We substitute the value of 1 and 2 where a and r are. Okay, so in the denominator you notice 1 minus 2 is a negative 1. Okay, so where the next step in this inequality is multiplying both sides by negative 1. Be very, very careful. Don't just copy and continue. When you multiply by negative 1, the inequality sign have to be flipped. Alright, so If you don't do that correctly here, your answer will be wrong. Then the next step is to take care of the. I would add 2 to the power of n to both sides and add 2 million to both sides. So then we will have to take logarithms here. The n will come and multiply by log of 2, and then we can divide by log of 2. Log of 2 is a positive number, and we don't have to divide. We are not dividing by negative value, so you leave the inequality sign exactly as it is. Okay, so the decimal value for n is n being bigger than 20.9. So nth value will be 21st. The 21st number will exceed 20 million. You can substitute it back into the formula if you wish, and you'll see that is correct. Alright, I'll see you in the next video.